Hey everyone, welcome to my channel. So today we'll be solving another problem in our DSA warm-up series, and this problem is about finding the largest number in an array. So we'd be given an input array and we are required to find the largest element in this array, right? So the first approach that might come to our mind would be, for example, sorting this input array, sort the input array, right? And then probably return the last element. Now you might wonder why the last element. It's because in most of our programming languages, the built-in sort method that we have arranges the elements in an ascending order, right? So the last element would be the largest one, and hence we would return the last element. So this approach, as a whole, it's like a brute force approach because it's pretty naive in its way. So this is a brute force approach, and in this approach, the time complexity would be the time complexity of the sort algorithm or any programming languages. It is around n log n, o of n log n. And since in this entire approach we are not using any auxiliary spaces, so the space complexity would be pretty easy. It's o of 1, right? So this is the brute force approach. Now you might wonder whether there would be an optimal approach, or maybe many of you have already guessed the optimal approach. So the optimal approach would be to iterate over this array and keep a track of the largest number encountered till the previous iteration and compare it with the current number. So to give you an example, for example, let me just write this one down. This is approach 2, 12774. So for this particular array, what we would do is we would start off with probably the second element. The reason being, we would store the first element in a variable called largest. So here I am storing it in this particular variable, right? Now I would progress or move this pointer ahead and compare each and every element with this largest value, right? So now our loop would start from here. So for this particular position, the current element is 5. So we would ask a question whether 5 is greater than what is stored in largest. In this case, it is yes. So we would copy this and overwrite whatever is stored here in largest, and we would move our pointer ahead. Right now, I points to 1. So in this case, also the same question whether 1 is greater than 5. The answer is clearly no. We would move ahead. Whether 2 is greater than 5. Nope. Whether this current element 7 is greater than 5. Yes. So we would copy 7 here and move our pointer ahead. Whether 7 is greater than 7. Nope. Again, whether 4 is greater than 7. Nope. And we finish our iteration. So with that approach, we have figured out the largest element, right? And this is actually better than the one that we already have, which is why it is also called a better approach, for the lack of better term. Anyway, this is a better approach, and in this case the time complexity is pretty easy to guess. We have done a iteration for every element minus 1, so it will be o of n minus 1. So we would ignore this constant minus 1 and all, so it's on an average o of n, right? And space complexity is similar to this one. We are not using any auxiliary spaces whatsoever, only one variable, and it's constant memory, so it would be o of 1. So now we have optimized on the time complexity, and I think this is the better approach. So yeah, this is it about this warm-up exercise. I would be uploading various other problems for various other patterns. You could check out the YouTube channel, my YouTube channel, and you would see the playlist that I've created. I would be creating many such playlists based on the DSA patterns rather than the lead code problems specifically. So that would be easier for all of us to practice and know the patterns in depth. I hope this is clear to you, and do let me know in the comments if you have any feedback for me. Yeah, so that's a wrap. Thanks a lot. Bye bye.